first one that we're likely a little bit more familiar with is our IEER. And this stands for Integrated Energy Efficiency Ratio, basically looking at 4 different conditions. So here we have point A, B, C, and D. They're weighted differently. So with these 4 outdoor conditions, I have an EER value that I can calculate from each one of these conditions. So for example, I would take the EER value at point A, I would take that times 0.02 and then combine that with the point from point B times 0.62 and get one integrated value. What you look at with this IEER test is in each one of these points, the return air never changes. So what's entering our indoor coil is always going to be 80-degree dry bulb, 67-degree wet bulb. So it represents a true recirc type application, or if we think about those VAV type applications. The other thing to point out is IER is weighted to 98% part load conditions. So as our efficiency minimums continue to increase, we have to focus on what components are the most efficient during part load conditions, not necessarily full load conditions. And this is actually designed after HRI 340-360. Typically that's for, again, 25% outdoor air and less. On the flip side, you have ISMRE. So very similar, it's integrated seasonal moisture removal efficiency, but that looks at 4 conditions. But one thing you'll notice is now it's truly looking at those exact same conditions entering that unit. So it's not a recirc application. We're really saying how efficient are we at removing moisture from the outside air, because this unit is a 100% outdoor unit, and this is where you need to make sure that we have this. And then one other thing you'll see with this is the weights change as well. A little bit more geared towards full capacity days just because you're designing more of your DOAS equipment for those full capacity days. However, still only 12% is your full load day. And this is test standard HRI 920. And again, this was really laid out to focus truly on those 100% outside air systems. The other thing with ISMRE to point out is, if you ever looked at your code breakdown, it never really looked at energy recovery versus non-energy recovery with IEER, because you're always entering at that same condition due to the amount of recirc. With ISMRE, because it's 100% outside air, there are different values and different minimum requirements with energy recovery versus without energy recovery. And the reason being is you can see, for example, on the left, without energy recovery, you have a DX system that is fully responsible to remove all the moisture. When you add energy recovery on, that's a total enthalpy device. So it actually reduces your moisture content as well before it enters the DX system. So even though I'm really humid outside, I'm taking a lot of that humidity out from my energy recovery device. So now my system doesn't have to work as hard, which means I don't have to spend as much energy on the same exact CFM. And that's where your efficiency values are changing a little bit. So where this all comes from, Department of Energy, right now, they only regulate IEER. So as a manufacturer, all of our products, we have to be listed with a minimum IEER that meets those requirements. With DOAS, typically in the past, it's either been misapplied and they've been using IEER for a true DOAS type system, or nobody was really looking at it. And what happened was July of last year, they are now requiring manufacturers to list an ISMRE2 value for all DX DOAS equipment. And then actually today, they were supposed to really require a minimum ISMRE2 value. They don't have their compliance management system built out quite yet, but that is something that they're working on. And again, the big takeaway is manufacturers have to list an ISMRE2 value, and in the future, they'll have to comply with minimums. So you'll get that true differentiation from the Department of Energy that basically says if you're partial recirc or a VAV, you follow these subsets of requirements. And if you're DOAS, now you're going to go to ISMRE2. You'll notice I said ISMRE2 on the last slide. So what changed? Before they really required this, they wanted to make sure that they fine-tuned some of the test procedures. So reheat is no longer required because applications do or don't require it when you're using this type of system. You can't over dehumidify and take credit for it. So this is basically saying whatever you dehumidify to during your full capacity conditions, you can only take credit for moisture removed to that same leaving dew point, even at your part load conditions. This is just ensuring that your efficiency, or you're using high efficient components. And then the last couple are just changing the static pressures, the weights of the conditions, and the actual outdoor conditions themselves to make sure that we are better representing the weather bin data, the applications we're serving, and then we have some more reliable testing that's more representative of actual conditions you'll see in labs as well. So what does this all mean? At a very, very high level, this is why you're seeing so many changes to all of the equipment from an outdoor air standpoint. So DOAS equipment, rooftop equipment, you're seeing the transition from the digital scroll compressors to the inverter scroll compressors. And that is because inverter scroll compressors are 15 to 20% more efficient at your part load conditions. So digital scrolls, great at capacity control, but they're still always using the same amount of energy, even at your part load conditions, versus your inverter scroll compressors, you add that VFD, now you slow down the frequency, which means you get energy savings. Micro channel coils, you get a little bit less pressure drop through the coils. They give you better heat rejection with a smaller coil. You use less refrigerant, so some benefits with the micro channel coils that we've seen. And then AC, more on-off type condenser fans, really getting towards that modulating condenser fan. So EC or VFD driven condenser fans, extremely important not only for efficiency, but if you do ever have applications where you talk about hot gas reheat, that is extremely important to have a modulating condenser fan so you can maintain better reheat capacity in your system. And then the last one, dual circuits to single circuits. A lot of this has to go into account with your coil designs and how much condenser fan energy you have to use based on the highest circuit that's being, or the highest compressor RPMs in that given circuit. So few benefits to single circuit, but condenser fan energy is the main one there.